in the heart of the urban jungle, a unique species of Homo sapiens thrives. Identified by their common adornments, the humble hoodie, their peculiar yet endearing rituals involving ping-pong tables, and an astonishing amount of free coffee. The startup Homo sapiens.
I'm no David Attenborough, but I know a thing or two about startups. For example, did you know they don't run on coffee alone?
I'm here to guide you on an extraordinary journey. Our new Twitch series, AWS Let's Build a Startup. Together we shall observe how an idea evolves, grows and matures into a real minimum viable product. All of this within the AWS ecosystem. Whether it's the thirst of knowledge guiding you or simply your passion for free caffeine. Join me on this fascinating journey.
Oh, hello, founders. Welcome back to AWS Let's Build a Startup. I'm here with Alexi and Sabia. Folks, thank you so much for joining me today. And this is a special episode because we're going to talk about the impact of generative AI on games and how to build a game based on, or like powered by generative AI. And I wanted to bring to you to experts, somebody that have been there, done that, got the t-shirt. But before we start, folks, this is AWS Let's Build a Startup. It's our 1 hour show that weekly dives deep into the success of startups that are building on AWS. I'm your host, Giuseppe Battista. I'm a Senior Solutions Architect at AWS, and I focus primarily on pre-Series A startups, so early stage. And I'm here, as I was saying, with Alexi and Sabia. Hey, folks, how's it going?
Good. Thanks for having us.
Thanks for having us. Nice to meet you.
Yeah, folks, so I'm super excited today because you folks have built something really, really interesting. I think it was the first type of game that was infused and imbued with the generative AI. I was really surprised when I tried, and I almost find it by accident. What brought you to build it? What is it? How can the folks on the chat actually start playing with it? I really want to learn all about it. And by the way, chat, if you have seen any interesting games powered by AI, just let us know in the chat. Let us also know where you're coming from. If you have experienced any interesting games built with generative AI in mind, super happy to learn about it. But Alexis and Sabia, what's the deal with Unraveling Shadows?
So Unraveling Shadows is a murder investigation game that is powered by AI. So the idea behind it is that you, as the player, are an investigator in a fictive murder scenario. And the murder scenario has been obviously generated by AI. And you have a few suspects with which you can interact with, and they are also backed by AI. And you asked an interesting question earlier, asking, okay, why did you build that? Because obviously playing a murder investigation game is fun, but the reason behind it was in 2023 when ChatGPT became super popular, and then OpenAI launched their model that you could use, etc. We thought, okay, what could be a good way to show the capabilities, the power of those new technologies? And we thought, okay, gamifying that would be a perfect way to do so. And that's where we came up with this initial idea, and then this idea has grown into becoming something more than just a small demo. And Sabia will cover that more into details.
And you folks are based off Dubai, right? So this is where the idea kind of grew, and I think your first showcase was the AWS Summit in Dubai.
Yes, we started last year, basically built a bit around it, and then we actually expanded on it with new capabilities. This year, basically capitalizing on the current trends, trying to see how we could still show new technology that's coming out in the community.
Yeah, that's great. Thanks for sharing that. But I think that maybe we really want to just get our hands dirty and maybe start solving some murders. What about that? And chat, please do let us know what you think about the game. If you would play something like that, if you had any featured requests, just let us know. and we'll be in touch with Sabia and Alexi to maybe add some features, maybe do some additional research around that. Let me know, Sabia, when you're ready to share your screen, and we'll
Yes.
pop it up.
Yeah, I am just
Absolutely.
about to do that. Hold on.
No worries. By the way, actually, while you do that, somebody told me it's your birthday today, so I would say I knew that you weren't so happy about that, but so chat, I think we can join and maybe send some birthday greetings to Sabia while she brings up the screen.
I'm sharing. I'm not sure if you can see it. I'm selecting my tab.
No, really. Oh, look at that.
Nice.
Hydrolix.
Let
And
me try to. Or it's not
yep,
working.
yep.
Okay, let me just do it.
No,
Love it.
I mean,
We did our.
this is the demo gods, right? So we need to please them somehow. I guess. Yeah, and while you do that, chat, let us know where you're coming from, and if you have any ideas for like building maybe your AI powered game. That'd be interesting to learn a bit more about. Or Alexei, I don't know if you can also share your screen. Maybe instead of doing the demo, we can jump into the architecture first, and then while we resolve the sharing screen issues, we can just talk about the architecture. What do you think?
Yeah, that will work. Let me, but maybe I can even show the demo if that
Yeah,
helps.
absolutely.
Let me
Let's
try. I'm
bring it
just
up.
trying another browser in case, because
Mm-hmm.
for some reason, tell me if this would work, because it's a bit of a mess.
Let me see. Ooh, I see something coming up. I see something coming up. That's a good sign. Sorry, folks. Technology, not really the best.
Sabia, do you need me to share my screen?
Yeah, I
I'm
think
sharing.
let's try that. Let's see.
If it's still troubling, then
Yeah, no, I don't see any live feed. I'm sorry.
for some reason it says that it's on the bottom. But anyways, let's
That's
just
okay.
go ahead.
Let's go ahead.
Let's switch it up.
Lexi, I don't know if you can you can share the demo yourself, and then we can bring it up.
Share it. All right. Tell me when you can see it. All right.
Yeah. Oh, where did it go? There you go. Unraveling shadows. So first of all, like, what's up with the title? What does it mean?
Yeah. So the idea behind the title is really, I mean, trying to unravel what happened, and that's during a murder. So that's where the link with shadows as well comes. But yeah. So that's that's the main page of the game, and in a nutshell, you can enter your investigator name. My name is Alexis. So I started the investigation, which will be basically be loading a new game. As part of the game, what we have here and what you can see is a scenario, and a scenario with a few suspects. It is a scenario that's uniquely generated. So basically, every game that you play is a different game. So you might want to try it again. You would see another game. So the idea is for the player to start interacting with the suspects, trying to understand whether Robert Sinclair was killed by Jessica, Emily, or Dr. Michael, and then really the idea is starting to click on one of the suspects and start interrogating them. So, for example, what was your relationship with the victim? Behind the scenes, the suspect is actually an LLM with a specific role, a context. I mean, they know things, they saw things, and they will try to help you if they are not the murderer. And obviously, the murderer will say, "Okay, I am obviously trying to deflect the possible, suspicions that I have on me." Right. So the idea is that you really will try to link what happened to what the suspects tell you, and at the end you will also be able to, based on your investigation, try to arrest one of the suspects by accusing one of them and arresting them. Okay. Um,
I've
so
seen that
that's
there's a timer at the top
yeah.
left corner. Is that the time you have to solve the crime?
Yeah, so basically, the idea behind it is also we wanted the games to be short-lived, specifically because we were using that during live events, for example, the AWS Summit and so on, to be able to encourage people to solve a case fast and make them short, but very interactive. So in a nutshell, what you've seen there is how the core game works. Now, at some point, we realized that some people might not want to actually play the game themselves, but they might be interested in seeing how it works and then start engaging in conversations about, okay, how could we build something similar with AWS technology? And that's where we thought, okay, what if we implemented an AI agent, an investigator agent that actually solves the murder for you on your behalf? And that's where we added a new feature, this beautiful icon of an AI investigator. And when the magic happens, where basically you can see the AI detective thoughts, and I'm
Well,
not touching my screen anymore, but basically the AI agent is taking control of the game on your behalf. And you can see that it starts interrogating the suspect, continuing the investigation, trying to really get to the bottom of what happened to ultimately decide to arrest one of the suspects.
And I also
And
see that there's a tab over there on the right, sorry, on the left top corner.
yeah,
That's the thoughts of the detective. That's
yeah,
so
yeah, it's
clever.
like a ThinkPad. Just to let you know, basically we'll look into it, but it basically will get the game to identify what kind of game you're playing. Because as Alexi said, every player plays a different game. It's never the same. So it needs to know what's going on and what actions you might have taken at this point and what it needs to do. So you see everything happening in real time. And also, by the way, there's a comment that's actually asking how long it took us to build. So we started the ideation late 2023. And then in 2024, we actually created the first iteration. So that was in May. So it took us a couple of months to build that. I think, let's say, 2.5 up to 3. And then we added newer features earlier this year for the summit that took place again in Dubai in May. So it took us a few months if you really put together.
But it was just you and Alexi, or is there anybody behind the scene helping you out?
So
Like,
it was us, and then we had another team member to join us this year to help us refine more of the features that you're seeing today.
oh wow, that's
Laura,
so cool.
shout out to you, Laura.
yeah,
But do you know the thing I'm thinking about, right? So you know, when I joined AWS as a solutions architect, I was kind of naive. I didn't think about like I didn't really know about sales or like anything related to like how to persuade people or like how to really listen to customers. And I know that this maybe not you know the idea that you started building this on, but like I can see how this could be like a training tool, for example, for like having like I don't know, you have like a huge number of like recorded sales calls or like even customer support calls and like how you know you have to kind of maybe interact with it. So you folks built something that it's a fantastic game. I really enjoy playing it, but also like I see how this could be a fantastic I don't know application for maybe training workforce, training your sales force, or like your customer support. So I think I don't know. Have you thought about that? Anything that's bringing into that direction?
Yeah, definitely. I think the main part was really to show patterns or let's say general workflows that it's easy to see when it's gamified, but actually you can apply it to other use cases and to different industries, right? So if we take the AI agent like investigator as an example, you can think of using the AI agent on, let's say, a SaaS platform where you have a user or a new employee basically registering, and you want them to understand the variety of features, let's say, on the platform. So instead of you having a guided tutorial, you tell the agent what you want, and it will help you out with that as a thinking process. Another thing we were thinking about is also how to improve the game moving forward. So what the AI agent is really doing is kind of thinking about the different steps it could, take to identify clues, right, from the suspects. So you're building data actually from that point, right? Synthetic data that then you can use to make the suspects a lot more harder, right? Make the games even longer and more convoluted. And there's like different phases to this. So that's actually pretty, that's really what our idea was. And we see this as we're talking to customers at the summits going, aha, okay, I can actually use this for this thing. I did not thought of that, right? So I think that's always a really good feedback to get live when we're having this demo run.
That's actually that's something I hadn't thought about. That's really interesting. I also saw that the investigation kind of failed. What happened there? Like, what was the chain of thought there? Because it's
I
difficult.
think
Because
I think the idea here is obviously that this AI investigator agent is a quite recent feature that we added, and it can certainly be improved. But in a nutshell, as well, there is the complexity of trying to solve the game where you don't have all the details, so you still need to make a wild guess, right? In the end, and that's also something we could improve over time by creating this synthetic data, by letting it play the game. But maybe just also for the sake of time, maybe if you're interested, we could go through the architecture, trying to explain how everything works, and not just show you an end product, but also how it works, if you're interested.
I'm absolutely super up for that. But before that, a question popped up. So, what kind of models are you using? And have you tried to switch your, let's say, investigator agent from one model to another? Because this looks to me like it could be some sort of like benchmark for like a agent performance or something like that. I see really a ton of application for this, folks. I'm so glad that you built it. It's really cool.
Maybe for the bit where we will which models are we using, I will cover it, because we are using different models in different spots, because they are more specialized for a specific aspect. So let me share my screen.
Yeah.
And yeah, we've prepared a small let's say architectural overview, just to start with. I mean, everything starts with your front end. I mean, you've seen it's a wonderful front end, hosted on AWS Amplify hosting, which allows you to host your front end applications. And in our case, it's a Next application. So it's a Vue.js framework that is available out there. Then we have the entry point to our backend, which is AWS AppSync. It's a GraphQL managed GraphQL API on AWS, and we decided to use that because we wanted to have this two-way communication between our front end and our backend, specifically because the game allows for multiplayer mode, even though we didn't show that today. So we have three ways to interact with our API. So to perform queries, so to retrieve data, mutation to modify data in your backend, and then subscriptions to listen to things happening in the backend. And all of this, with all of this, the AWS AppSync API connects to data sources that allow us to basically directly communicate with AWS services to perform different things. So if we look at the role of AppSync in all this, we have a series of things that we can query. Basically, we can retrieve games, then we can mutate the data and listen to things happening in the backend. So if we dive deeper into how a game is created, because that's where one of the questions that you've asked earlier, Giuseppe, about which models are we using. For example, for creating a game, we are using Sonnet
3.
we could
3.5.
Sorry,
Yeah.
Okay, 3.5. But we decided to use a bigger model than the ones that we use, for example, for interrogating suspects. And why is that? Because we start by generating a full police report, so full flow of events, what happened and why it happened. And then we are able to leverage another model to actually extract the data and format in a way that we can then validate and store in our database. Then obviously you saw some of the suspects having avatars. So we thought, okay, we need to generate images for each of those suspects based on their traits, based on who they are. That's where we are using stable diffusion models to actually generate those images. And then finally,
the stable diffusion is the one hosted on Bedrock, right? So this is, I think
Yes.
one of the coolest thing about this is that if I understood correctly, it's almost all, or like maybe 100% serverless. Like there is no like long compute tasks that are going on, right? So you're orchestrating this with what we're seeing here on the screen, folks, is a step function workflow, right? So this is the one that generates new games.
Yeah.
If I understood correctly. Okay, sounds good. So you've generated the police report, you generated the images. What is it that we're looking at right now?
And then the last part in the workflow is basically once we have generated the full, if you want, synthetic data about the game, we are actually storing it and then emitting an event to whoever is interested. Basically saying, okay, the game is ready to play, and that's most likely when you will see the game appear on your screen. And then obviously the fun starts. It's when you start interacting with the suspects, right? I will not cover all the mutations and subscriptions, but I think this one is quite interesting because it all starts with you entering, talking with your suspect and entering the questions that you might have for one of the suspect. Basically what you are doing under the hood, you're triggering a mutation with AppSync, which in turn will trigger what we call a pipeline resolver. So it's a series of, let's say, a function that you execute sequentially, and that will allow you to talk to different data sources. And that's where we don't really leverage any compute layer. We are directly talking from our API to our data sources. So the first thing is we will obviously load the full chat history that you had with a specific suspect from DynamoDB. Then we will store the message that you sent in DynamoDB. We will then emit an event for all connected front ends. So basically all front ends that are connected to this game. And that's where the multiplayer mode comes into the picture because it is emitted back to the front end, and that's where it appears in the chat interface. Then we are actually generating a response with Amazon Bedrock. And as you can see here, we are using Haiku 3.5. And the reason for that is that we wanted a smaller model for faster responses. And when we played the game, you could see that the responses were pretty fast. And what we're providing to the model is a system prompt with the full context of in the context in which they operate, who they are, what they did, what they saw, whether they are the murderer or not, and based on that, additional instructions about deflecting suspicions and so on. And then we are also adding the chat history, which we, once the response has been generated, we store it in DynamoDB, and then we emit it back to the front end, and that's where you see it appear. So that's really the full, let's say, interaction flow when you interrogate one of the suspects.
That's beautiful. And sorry, go ahead.
No, I just noticed that there was a question, and we were actually having a chat about this, and the question was like, how much does it really cost, right? And it was apparently what we figured is, let's say if we have roughly, how many was it, 30 games also? 30 games if we had, it will cost us, let's say, an entire of 17 cents, I believe, where 12 cents is for just like the image generation, because obviously if you notice the images are really nice and categorized based on the descriptions, and then just really 4 cents for the LLMs, basically responses. That's to give you a rough idea.
Less than 1 cent per game. That's fantastic.
basically.
Like I was thinking like, oh, maybe, you can optimize the cost by maybe you can cache the images, like you can build like some sort of a semantic cache for the image and say, oh, I don't know if we have generated a certain doctor or whatever, like
Mhm.
maybe we already have a pool. But like
Could be a good
actually
idea.
maybe we're not really in the territory of needing any sort of cost optimization at this point because it's, if it's less than a cent for
But
per game, it's like, let's add new features, folks.
yeah, but the idea is also that 70% of the cost comes from image
Comes from
generation. So
images.
basically, at scale, it
Yeah.
Ah.
could be interesting, right?
I think
You,
Very
because
interesting.
we put 30 games, but let's say during the summit we've actually crossed a lot more, and that is when we would need to then think about it. So I think it's a good idea. We should probably put it
Yeah,
into.
I I actually have a customer that could help with that. By the way, it's we had them for our first episode here. Let's build a startup. They're called LanceDB. You can go and check the first episode of this series because they're building amazing thing when it comes to multimodal lake houses. But yeah, I will get you in touch there because I think that like having that semantic cache could help. Like something like I'm generating this profile, but actually there's something that, in my vector database um, that resembles that quite okay. So it'd be interesting. So like let's say that you can bring the costs down of that even further because you said that 80% of the cost of the image generation.
70%, yeah.
70.
70%. Wow, that's crazy. But also super interesting. I'm wondering, what the next steps are for this. I think that you potentially have bumped into challenges maybe around observability or I think in like understanding exactly maybe how the solving agent is performing as well because I was thinking, let's say that we use Unraveling Shadows as like the test bed for agents, like
Mhm.
the test bed for models and actually able to like reason. So it's likely that this is going to generate a ton of data, right?
Yeah. So maybe I will go quickly, try to go very quickly into how the agent bit works,
Mm-hmm.
because what you will see is that everything that happens is an event, so we can listen to that, right? So in the front end, when I activated the AI mode, it just triggered a mutation and another step function workflow where we are basically retrieving the game context. And then we are invoking an LLM with a set of tools. Basically, you can interrogate a suspect or you can arrest a suspect. And what happens whenever it decides to invoke a tool, we will emit an event that is picked up by EventBridge, sent back to the front end, saying, okay, those are my thoughts. Um, it will execute a specific action in the front end. Once this action has finished executing it, it will send it back to the step function workflow, which was on pause from that point on. And it will basically go into another loop of reinvoking another iteration. Basically, okay, now the detective decides to arrest one of the suspects, and that's what you saw at the end, him trying to say, okay, I think it's, for example, Emily Ahais, based on a specific reasoning. So that's really the core idea behind the AI investigator. But throughout the game, what you saw is that everything is an event. So we decided that every communication between every system is an event. So you could very easily pick up those events and then do whatever you want. So plug let's say an observability suite on top of EventBridge to actually ingest this data and then reason about that data to, for example, improve the game or improve some operations if you're in another context.
That is absolutely beautifully designed. I really love it. The fact that, it's completely serverless. It costs really nothing to generate a game. And I see a lot of applications here. Not only like this could be like the baseline for like testing some models or like testing your implementation, becoming something like I don't know, at the very beginning of generative AI, you've seen like maybe folks that were using models to like play Pokemon or play like Tekken or something like maybe Street Fighter or something like that. But anyways, I think that that's an interesting cue to actually bring in our experts for today in terms of observability. So I am super pleased to add to our virtual stage folks, and please help me welcoming them. Our friends from Hydrolix. So we have Rory and David actually joining us. Folks, I'm bringing you up to stage, so I hope that you're presentable. Hey Rory, how's it going? Hello, David.
Hello.
Hey.
Yeah. So, what do you think about Unraveling Shadow? Would it be something that you would spend hours playing on?
I would definitely give it a go for sure. Yes.
Yeah. So I love the way that they, Alexi and Sabi, they've built this incredible serverless and GenAI powered game, right? So, but we were chatting about the fact that this is actually producing so many events, and I guess that you folks are specialists in handling this sort of challenges. Because I'm thinking if we were to have maybe hundreds of thousands of games a day, or like hundreds of thousands of simulation through the agent, this is going to produce so much data. And I know that you folks have handled a pretty hefty events this year, I think, with the Hydrolix. Can you let us know a little bit more about that?
Sure. So typically Hydrolix handle terabyte of data a day and even a minute. So typically we worked on the Super Bowl with Fox this year. And for the Super Bowl, Fox was actually streaming the Super Bowl with multiple CDNs. And so for people that don't really know what the Super Bowl is, it's basically, for us in Europe, it's like soccer. And for like in India, it's like cricket. It's a massive sporting event where you have millions of concurrent viewers watching the game in real time.
200. You said 200 terabytes a day. Is that how much data you crunch in that day?
Yeah, for that, actually, not for a day. It was actually for the duration of the Super Bowl, for like 6 hours. It was 200 terabyte. At some point during the peak, it was 1 terabyte a minute of event that was coming into the platform. So pretty massive scale, yeah.
And did you have any issue during this event or not? You will say no.
No, it actually went beautifully. Like it really worked well. But the tricky bit is it's really hard to test those kind of events because it's really difficult to generate that much data. So we knew in theory how it would scale, but it's always really, really difficult to figure out if it's actually going to scale that way. But it did, yeah.
I mean, you're battle tested now, so I mean, I think you're ready to onboard Unraveling Shadow when we're going to like share it to everybody and start generating hundreds of those thousands of games per second, I guess. So that's mind blowing, folks, and I really want to get my teeth into how you build it, the kind of challenges that you had, what are your customers are asking for. So yeah, I would say, why don't we get ourselves into a demo and then we maybe talk about some of these challenges, some of the architecture behind it, and I'm really curious about how you folks have managed to handle that much data, because to me it's all theoretical, right? I left the production I left the production world a long time ago, and I wouldn't really know how to handle that sort of traffic.
Sure. For the demo purposes, we can show a small live stream. I mean, it's actually not a live stream, but it's technically the Big Bug Bunny video. So this is typically what we provide. So here on the left side of the screen, the video is actually running, and you can see my session name is Edible Schema, which is a really strange session name. We generate session name dynamically with dictionary, so sometimes we have really strange names. And you can see here the total number of sessions that are watching the video in real time. And what's going on technically is I'm streaming the video in my browser so I can see the video here. And at the same time, Hydrolix is capturing the logs from CloudFront, which is the CDN that's being used to deliver the video. And from the CDN log, I actually extract a lot of information that is really relevant for video streaming. So I can get information about the bitrate, so what is the quality of the video that the user is currently playing. I have information about the offload, so am I getting content in the CDN cache and all of that. And so you can really see all the details about all the information available from the CDN directly here. So this is technically the raw logs that we're collecting, and we're extracting some specific information like CMCD information, which is the client media information. And so we're extracting all of that and indexing all that information into Hydrolix in real time. So this is a small scale in the sense that we are not a lot of people watching this video. But imagine if you have millions of people watching this video. This is technically video fragment that are 2 seconds. And so every 2 seconds, you have a log that's been generated, that's been sent into Hydrolix, which for the Super Bowl at some point generated a terabyte a minute of log, right?
Mind blowing.
So,
and
yeah.
Yeah. So I was wondering, folks, if how this would translate maybe for a sort of like gaming experience, like because in here like we're talking about having customers consuming video from a CDN, but like what are the challenges that are associated with maybe a live gaming experience? Because this is what I would like maybe to adopt for Unraveling Shadows.
So gaming is kind of moving towards more real-time streaming, right? If you think about it, you have user interaction online that are repeatable, that you can see, and that when a user take an action, another user take another action, etc. And all of that needs to be tracked and observed, right? And so think about when you press a keystroke in your keyboard, you want to capture that information. And all of those events represent tons of metrics and logs that are going back into the gaming platform at the end of the day. Like one of the big things that gaming platforms are trying to avoid is doing both mitigation. So I want to know if someone installed software that's improving how my mouse is moving to improve my aim, for example. And so one of the key things is to analyze how fast is the mouse moving across a variety of users to figure out if I see differences between user A and both potentially. And so all of that multiplied by millions of users generates terabyte and terabyte of data point at the end of the day. So similar to a live streaming experience, like returning keystroke, how fast is the mouse movement and all of that. If you want to start capturing all of that, that's generating a ton of data. So
I'll chime in a little bit. It struck me as I was watching the awesome Unraveling Shadows presentation. Kudos, Alexi and Sobia, and happy birthday again, Sobia. We're kind of talking also about investigations. It's an analogy, so go with me, folks, but it's true. So when you need to investigate something, like the use case David just gave, so you may have bad actors interacting with your game. So you need to investigate. In that case, they're like the murderer, right? Who is the bad actor? Because games deliver such a vast amount of information across such a broad range of different device types and geolocations, just like the whole of the internet, basically. It's very easy to make a data trade-off where you don't have the facts to investigate to the level of detail that you require. So if you imagine, if we take that analogy of Unraveling Shadows and place it into the operating a live ops game, imagine if you had actually complete data sets with application logs, with CDN logs, with WAF logs potentially, and you could go and look at the atomic detail of how users are interacting with your application. That's kind of the premise of Hydrolix. Historically, customers would get rid of as much data as possible at source because it was too expensive to keep it. So things like CDN logs, your observability platforms would struggle with, or you'd struggle with keeping them in a cost-efficient manner. The reason why Hydrolix exists is to give you, as the detectives, every piece of information you need to investigate an issue. Could be a security issue, could be a performance issue. Maybe a portion of your users are having an issue in a specific ASN or IP address sort of subnet in a specific part of the world. Again, you need facts. So putting your detective hat on, imagine if you had only a small amount of facts, Hydrolix could give you all the facts that you need to investigate that issue.
And I suppose you're helping basically customers or investigators ingest all this data and have access to it in a, let's say, a reasonable way to make sense of it. I suppose that you're at some point also exposing this data through connectors, to actually consume the data to make sense of it, right? Or are you doing that part as well?
So we do a lot of things. Typically, we build a really big ingest system that allows us to triage the data, if you think about it. Like if you expect some certain field to be like only up to a specific numerical value, we can say, okay, this value doesn't, like, it shouldn't be there, so we can discard that data. So we can pre-filter the data as it's coming to make sure that it's actually good data. But what we also do is also pre-aggregate that data. So if you know you're going to have the same question over and over again, instead of going through billions of logs all the time, we can pre-aggregate a summarized view of that data, and we can say, okay, I want to know for every 1 minute the evolution of my throughput, for example, per country. So that's the kind of pre-aggregated state that we can keep, so you don't have to worry about it. And the last bit is we expose all that data, yes, through different API. One of them, the main one, is SQL API, but we also support Spark. We also support Elastic Query DSL, and we released an MCP server to be able to talk through LLMs, and so LLMs can interconnect to Hydrolix and ask questions about the data that we have. So yes.
Yeah, and I wanted to throw into the mix there. Part of the interesting thing that Gen AI in general opens up is non-technical, non-data sciencey users get access to data in a way which they can answer questions quickly. So in my career, whenever it's been like a data question, typically it has to go to a special team. And they have to like qualify the question, and there's back and forth between maybe a business stakeholder, maybe in the product team, maybe in the marketing team. And that's like, it's been a clumsy process ever since I've been around, like data. Go to people who don't have the context that you have, try and get the context from your head into their head, try and get them to construct a query to make the answer that you want magically appear. But typically it's not the answer that you want straight away. It takes like iterations. This is time, this is pain. So if you had, again, I love an analogy, so I'll run with it. If you had all of the facts for your investigation in one place, and then you're able to query it using natural language, for example, like that's super powerful, because then you can start picking out, like the use cases are so varied and so wild. Like you could be in marketing, you could say, what was my best campaign? Which was my best title in country X in the summer of last year? And you could plan maybe your marketing spend next year. You could be an operator, and you could be saying, which is my most troublesome internet service provider in the world? And you could maybe pick up a discussion with that internet service provider. You could say, across my 3 CDNs, which is the one which I should be putting most of my traffic on because they're performing the best? All of these sorts of questions become, all of these things should be right at front and center. Obviously, I was on the CloudFront team for 5 years, so I'll concur with you, Giuseppe. But all of these things become a thing that a non-technical stakeholder can do. Wasn't possible before.
And it's interesting what you're saying, and I had a question regarding mixing what you said and what David said earlier. David, you mentioned about you talked about an MCP server. Did you create it to expose it to other, third-party AI services to allow your users to interact in a let's say natural language with your data? Or did you also implemented an internal AI system that allows your users to interact with the natural language with your data?
It's both, actually. So it's quite funny. Like for us, MCP was the building blocks to allow us to build services on top of it. And so one of the key services was obviously interact with other LLM and just like open it up so people can use their own language and their own model directly to interact with Hydrolix, but also build our model on top of Hydrolix data and interact through MCP the same way. And so for us, it was really like the foundation piece that we wanted to build out as part of the product. So yeah.
So a lot of flexibility for the users.
Yes, exactly. Yeah.
I think that's an important point as well. One thing that Hydrolix has as its architectural kind of core principle is the data is not in a jail. So the data belongs to whichever platform you want to interact with. So it's standard SQL to query it, right? So I would caution anyone out there who's looking at a data platform which uses a proprietary query language that's separate from something everyone else uses. Try and be flexible and try and go with vendors that data should have value beyond the specific like bucket it sits in, right? Data should be valuable in a bunch of different contexts. And that's kind of what David has done such an amazing job working on with the product. Make it so that, you know, other front ends, data visualization front ends, can dip into the world of Hydrolix and bring that data up in a way that's familiar to users.
The goal was really to build a single source of truth that's highly accessible and that can be leveraged by pretty much any tools that exist in the market. And so whoever wants to use it, we would build connector, we would build REST API, we have a Splunk application, we've built a Kibana proxy application. Like the goal is really to be as flexible as possible. So because people are used to query language and they are used to data visualization, I don't necessarily want them to switch to different tools. And I don't want to build that tools either because it's not, I mean, it's not our thing. But I want to be compatible with pretty much anything that exists, so it's easier for people to use.
And sorry, I had a question, and this is on behalf of one of my customers actually. So I've seen you folks have built this dashboard for Bunny, but like, so is that the result of like some engineering work, building like a custom dashboard, or do you also have like dashboarding tools, something like that?
So we typically use Grafana a lot, and we have Grafana pretty much bundled by default when people are using Hydrolix, because I mean, everyone is pretty much using Grafana. It's becoming standard. We've built a plugin for Grafana. And we have default dashboard that we provide also on a per services basis. So we have integration done with Elemental, with different CDN vendors, and we have pre-built dashboard for those. But people can also build their own dashboard and their own alerting based on whatever they feel is necessary. And what we're working on, which is quite exciting, is an AI agent to help build dashboard. So the same way you interact with your data, is you ask question about your data. Your goal is to ask the same question but generate a chart out of that and then put it into a dashboard that you can then use. So
yeah, no, that's really cool, because I'm thinking, especially for Grafana, you know, you can have these JSON exports of the dashboard, so it really, I think it's really well versed to be like generated as well. So that's I mean, that could be a feature of, or like a product in itself, to be honest, just based on Hydrolix. But that's really, really cool. So is that what you're thinking about? Like it's you know, an agent that is able to have a look at the data that you're ingesting and then guided by a human investigator, maybe even just creating dashboards on the fly, right?
Literally, that's exactly the type of workflow we're thinking of. Is really, I have users that are asking question about their data, and when they get an answer, the question is then, do you want a chart out of that, and do you want to export that into a dashboard? And if so, what is the name of the dashboard? And create that experience ongoing for users. So yeah.
That's super interesting. The other question I had is that you know, this show is called Let's Build a Startup. I know your business is quite young. Like, so how big is your team? Where are you folks based? Are you hiring, asking for a friend? And what is you know, how long have you been on the market? How did you folks manage to get so like well spread on the market? I'm super curious.
So the company itself is now 7 years old. So founded in 2018. The product, I would say, is more around like 4 years old. Like initially, what we built was really a prototype of Hydrolix running fully into AWS. The founding idea of Hydrolix was there's a lot of app-only data that are immutable that we need to be able to index and query really efficiently. And so we focused on be able to compress and index that data really well, push that into cloud storage, and be able to retrieve that efficiently. And so the prototype was only running on AWS with EC2 instances, running CloudFormation, running on S3 and everything. And once we realized that the prototype was working, we're like, okay, now let's see if we can move it across clouds. So we moved into a Kubernetes environment. We built our own operators, and now we're multi-cloud service that can deliver the same kind of performance everywhere. But the goal is really to have this Kubernetes operator to be able to deploy and manage Hydrolix pretty much anywhere. And part of that was really interesting. We started building a white label solution. We have one big partner, which is Akamai, which is selling Traffic Peak, which is a CDN observability solution for Akamai customers running on Akamai Connected Cloud. We also have Hydrolix for AWS that's available through the marketplace. But what we realized was historically we wanted to build a software that people could use to really put all their app-on-lead workflow on. But it's not starting from a blank canvas. It's people were not super comfortable with having a software that they would run and where they just put their app-on-lead data. And so we started building really modules on top of that, and that's where really things started to pick up. When we added all the CDN modules to be able to ingest all the CDN logs from different vendors into a single platform, that's really when we really shine as a company, right? Historically, it was difficult to sell a pure software for just app-on-lead data, but selling an observability platform for CDN was something that was really successful for us. And now we have at 200 people within the company. So the company grew quite a lot. And from last year, we multiplied by 8 the revenue and the number of customers. So it started to really get a bit crazy lately.
Yeah. And I can see only going up, because I'm thinking not only I know you folks have started with the CDN, but I'm thinking all of these systems that are producing
There's
logs
so
in
many,
real time.
web application firewall, DNS logs. There's so many systems that are just pure app-on-lead that you want observability. That's
I'm thinking the proliferation of agents, and the agents are interesting themselves because there are a lot of cruxes, there are a lot of specific points where they have to kind of make a decision. And that is where I would love to have auditability and observability. So
yes.
I think that's absolutely.
And it's also a requirement legally for Europe. If you look at it, in Europe, there's a lot of models that are being trained that you need to have information about how the model was trained and how it infers information based on what it used. And so all of that you need to take into account, and you need to keep record of that. And if you think about, I was reading an article about how much how much Anthropic and others are crawling the web. The amount of data they're pooling now is completely insane. It's probably more than Google almost. And so all of that, at some point they need to keep an audit trace of and what they did and how it infer and what happened on their model out of that. So that's going to be a lot of data to manage for sure.
Absolutely. So we're slowly getting to the end of today's stream, but I wanted to close with actually a call to action for all you folks. So if you have any workloads that are requiring you to crunch streaming data at high volumes, I'm sharing a link now on all of our platforms. This is where you can actually get in touch with Hydrolix through the AWS Marketplace. And just another comment on the marketplace, folks. So in what modalities you can actually consume Hydrolix? Just very quickly before we close. I know you folks have started with deployments onto your customers' cloud accounts.
So we have different model. The SaaS marketplace is really a model where we actually host the compute, but the customer data lives in the customer AWS account with their own S3 bucket. So they produce the data in their account, they store the data in their account, but all the compute to ingest and to query the data is within the Hydrolix account. We also have another model where everything is hosted within the customer account. So for really large company like Fox or companies like that, where they actually have bigger discount than us with AWS, it actually makes no sense for them to pay compute resources on another vendor. And so we have multiple models like that where we can have shared resources. So we can have either compute resources on Hydrolix account or fully everything into the customer account, depending on whatever the customer feels comfortable with.
Beautiful. So, folks, we are unfortunately out of time for today, but I'm super excited to have had you here with me, Rory, David, Alexei, and Sylvia. Thank you so much for sharing your experience in like building cool games and observability into games and understanding what's the impact of generative AI in games. We'll be live again next week, actually, diving deeper into the AWS marketplace and the role it plays into actually opening up commercial avenues for startups. So if you're interested in actually making money on AWS and not just spending money on infrastructure, please join us next week on Tuesday, 2 p.m. BST, 9 a.m. I think it's Eastern, and sadly 6 a.m. In Seattle time or PST time. This has been Let's Build a Startup on the various platform that we stream on, so Twitch, YouTube, and LinkedIn. Please join us next week. But again, thank you, Team Hydrolix. Thank you so much, Team Unraveling Shadows. I'm gonna close the stream now, but up to next week, I'll see you soon. And now go build. Bye.